Okay, I think now I'm audible. Let's see if after screen sharing I'm also audible. Screen one. Sure. Okay, I think now I'm audible. What gone? Sound gone? Or am I audible or not? Okay. So now I am using phone's camera and phone's mic. I don't know how its mic work. How great is its mic? So okay, let me just move this bulb. Okay. So let me open history file, open close tabs. Okay, okay. History reopen was closed. Window. Okay. Okay, so we were discussing this problem. Okay, you are given an into a matrix grid where each value switch to follow the tree. Okay, so the problem was saying that we have a grid and each value in the cell represents a elevation, and we have a time t, means at time t we have a depth of water as t, and we can move to adjacent cells in means four directions: left, right, up, down. If and only if the depth of the water, means time is representing depth of the water. So if depth of the water is greater than or equal to this maximum of the two cells, means suppose if we want to move from 0 to this second cell, then the maximum value is 2. So we need at least t depth of water to move from 0 to 2. Okay. So at the end, what we need to do is we need to move to the last corner cells at the index n minus 1 and n minus 1, and we need to return this time, minimum time in which we can reach. Okay, so what we can do is I'm thinking that we can go greedily, like from the current cell, we can move to the cell which is, let's say, means moving to adjacent cell is easy for us, means from this zeroth cell we need 1 unit of time to move to this cell, because this currently the time is 0 at this cell, but we need at least one time to move to this cell and two time to move to this cell, and then we can move to this cell. Okay, similarly I think what we are doing here is from the zero cell we can move to this cell in, let's say, one time, and if we want to move to this cell we need 24 unit of time. Okay. Similarly, we are moving to next positions greedily. And when we come here, the time becomes 16. So now from 16 to move from 16 to 20, we need four extra 4 units of time. But to move to 15, we don't need any time, because now the elevation of this cell is 15 and the depth of the water is which is depth is equal to T, which is 16. So our depth will be greater than the maximum of greater or equal than the maximum of these two values. So we don't need any time to move from 16 to 15. Okay. Mhm. 15 to 50 size means grid is has 15 to 50 dimensions at max, and value of the cell is smaller than equal to this, and each value is unique in our grid. Okay. If each value is unique, then we just don't. Okay, we can have equal situation. Okay. You are given an internal value grid ij represent the elevation at that point ij. The rain starts to fall at time t. The depth of the water everywhere is d. Okay, at time t, the depth of the water is v. It's not clear in the question that the time will start from zero. Means what if in these both cases the first cell is zero, so we can start with zero. What if this value is greater than zero? Then in that case, should we start from that value, means that value of time, or something else? You can swim four directionally only if the elevation of both the squares individually at most t. I'm thinking of something like using a priority queue, uh, means suppose we are at this position and we can decide which edge to choose. Means we have this edge, we have this edge, so we can choose the current minimum edge, means we have in our queue, and can move to that particular edge. Means it's something like going greedily. Means I think that that should work. We can't move here. This is best possible. It's like deciding in the prism algorithm that which next edge we need to move. Means we will move to the edge which is having the which will take a minimum time to reach. Okay. and we need to increase time only if we encounter some edge which is greater than the current edge, means if adjacent edge is. You are saying greedily, but think of an edge case. Okay. 0 to 2, 1 2. Convert from 0 to 2, 0 to 1. Okay. Can you give a example? It's I think it's different from path cost, because in grid path problem, if we move from a particular cell to the next cell, we definitely have to take that value. But here we can move from a cell to another cell, like we can move from 16 to 15 without any increment in our value, means from this 16 to this 6 we are moving without incrementing time. Means here we can have options where we just don't need to increment our time, means we can have such nodes, moving from which to the adjacent node will not cause us to pay any cost. Let's see. I was thinking of approach, means similar to using a prisms algorithm, means where we can choose the edges greedily. Grid path cost. This is what I'm not able to. Okay. I don't find any example. It may be failed, but we can. Okay, 3 into 3 grid. Let me go to this. Okay, like we have this grid. So suppose initially we have a time time equal to 1, then only can move to this particular point, elevation point. So now what we can do? First we can move to this position. Okay. So now our time have become 2. Okay, because we at least need time 2, and we can put this cell in our, let's say, priority queue. Okay, now from this 2, the best option we have is, okay, we what we will do, we will suppose we start from here. Initially this is in our priority queue, means to reach this node we need 1 unit of time. Okay, then what we do, we will go for it neighbors, and we put this 2 value, and in order to move to this 2 value, our time is 1, so we need this 2 time at least. And to move to this particular value, let's put this into the priority queue. Yes, 1 8 9 9 10 is optimal, but let's see how our this queue behaves here. Since we will put 8 and this 2 into priority queue, and we will pop out 2 because this is initially minimum. So whatever time will become, it will become 2. Means at this stage while we are putting, our time is 1, and when we pop out 2, and we will fill it with the neighbors of the 2. So neighbors of the 2 will be 3, then we will have 8 in priority queue, and 33. This will be time equals to 2, because we are doing this for time equal to 2. Now minimum is 3. So what we will do, for time equal to 3, we will pop out 3, and for 3 we will put 14. Only 14 is unvisited, so now we are left with the 8. Okay, 8, 14, and we are left with 33. So this is at the time equal to 3. So now in our priority queue we have minimum time is as 8. Okay, so what we can do, we can pop out 8 and its neighbor will be 9, so we can put 9. So I'm maintaining a min priority queue. We can put 9. 33 is already visited, 14 and 33. This will be at time equals to 8. Okay, so now we can pop out 9 and its neighbor is 10, 14 and 33 are in queue. This is at time 9. Okay, maybe using greedy for grid path cost will fail here, because what we will do in grid path cost, we will go from 1 to 2, then 2 to 3, then we take minimum as 14, then we will after 14 we add 11, so we take that path. But here we don't need to sum up the value, we just need to decide the current minimum route we can take. And after 10 we have 14, 11 in the queue, 14 and 33, and this is at this particular time. and then we can pop out 11, and popping out 11 will give us our answer 11. Okay, so I think priority queue will work here. Okay, so what we can do, we can create a priority queue. Okay, yes, it's Dicastra. I think it's Dicastra. Okay, I think we have used a similar kind of approach in Prism algorithm, but where there we have to visit all the edges. Okay, let's first code this down without wasting much time. So we have this priority queue. We will store a priority queue. Okay, so we will what we will do, we will create priority queue with ij and weight. Okay, and we will sort it on based on this weight, means the minimum weight at the top. So this is a priority queue which will store value based on the second index in increasing order, means minimum values are at the top, and initially we are at this particular index, so we can put its value. So pq dot add, we are at 0 0 index, and its value will be maximum time to reach it, means grid of ij 0 0, sorry, we don't have ij initialized, we don't have any variables ij. Okay, so now we also need a visited array. We can track that, we can't backtrack a array. Okay, so boolean visited, its size will be, okay, so it will be a 2D visited array. So we can define our n and m also. So n will be grid dot length, and m will be a grid 0 dot length. Ngth. Okay. This is n. This is m. So while our static is not empty, we can pop out current cell data, which will be pq dot poll, and initially the time is 0. We need to return the maximum time, means we can take to reach the this particular corner bottom right cell, which will be n minus 1 n minus 1, so we can return time. So this is our current cell. Okay, so the elevation, so let's say I will be this cell data 0, j will be cell data 1, and weight will be cell data 2. Okay, so we can mark this particular cell as visited. Okay, before marking this as visited, we can see if it isn't already visited. So wait a second. Okay, okay, we will put the next cells in our priority queue. Okay, if this particular cell is already visited, ijth cell, then we can move to the okay, we also need to check. Okay, otherwise we will mark it as visited. And now what we will do, we will compare our current time with this weight, means the elevation of this point. So our time will be if it's if our time is smaller. Okay, so our time will be maximum of the current time we are having, and this weight. Okay, so we are basically increasing our time to this weight if it's smaller than our weight. Otherwise, if it's greater than our weight, then we are keeping this time only. Means our depth, we can say, means time will be equal to depth. So at time t, the depth will be t. And now we can check that thing. I think that if our I equals to n minus 1, okay, one thing, we have an n m equal, so we don't need separate variables. So if our I equals to n minus 1 and our j equals to n minus 1, then we can return this time, or we can break, because we are returning time at the end. So what do you think? Till now I think we are implementing it correctly. Now we can move to adjacent cells, means into these all the four directions. So we can create the direction vector. Okay, 0 minus 1, 1 0, and 0 1. Okay, so we will move into these four directions, and our x point, the new direction which we will be moving to, will be this. X will be this, y will be j plus dir of 1. Okay, okay, so if our X is math dot minimum of xy is greater than equal to 0, and our x is x and y math dot max of xy is smaller than n, then n not visited, or x and y should not be visited. We can put them into q, means pq dot add new int this x and y value, and its weight will be grid of xy. Okay. Visited. Okay. Okay, this will be the edge case if we only have one elevation point. This is correct. The current cell data is we are pulling out our priority queue. Current cell data is this ijk, ijw. Okay. If it's visited, we can already visited, we can continue. Otherwise, we can mark it as visited. The time will be the maximum of the current time and the time we require to move to that particular elevation point. And if both we reach at the end, then we have found the answer. We can break and return this answer. And we are transversing our directions. X will be this, Y will be this. Okay. If math dot minimum is greater than this, and okay, within constraints, and it's not visited, the neighbor is not visited, then we can add it to the priority queue. Okay. Okay, we have a issue in this dir variable. Okay. Okay. Nice. Okay. Okay, perfect. Okay, now we can continue dynamic programming. So tomorrow, what we will do, we will solve this problem and then start dynamic programming. So okay, so the last submission was in 22. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money. All houses at this place are arranged in a circle. Okay. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Okay. So basically, this house is the neighbor of this house, and this house is a neighbor of the this house. Okay. An adjacent houses has the security system connected, and it will automatically contact the police if two adjacent houses were broken on to the same night. Okay. Given a integer and nums representing the amount of money each of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay. So in house robber one, the only difference was we didn't have a circular condition. Means there the uh, houses were in line. So here the houses are arranged in circle. Okay, this means if we have chosen this house, we cannot choose this house because these are adjacent. The only difference is this. Okay, we cannot choose these two houses. Okay, okay, how we can solve this? You are a professional robber planning to rob houses along the street. Each house certain amount of money is stashed. All houses at the place are in arranged in a circle. That means the first house is the neighbor of last one. Meanwhile, adjacent house is a security system. Okay. We need to figure out how we can solve this. Means if we have taken this house, we also cannot take the last house. Okay. Means if we rob this house too, we cannot rob this house because this is in circular and this house will become adjacent to this. We can only rob a single house here, means either this, either this, either this. Okay. Similarly, here if here we cannot rob this house if we rob this house because these are adjacent. Okay. Means if the index of this house is 0 and our last house is the n minus 1, where n will be the length of nums dot length in GTH. Okay, so this is the first house at 0 index. This is the last house at n minus 1 index. Means if we have chosen this index, we can't choose this index. means we can maintain a boolean value like we have visited if we have chosen the first house or not. If we have chosen the first house, we can suppose take that boolean as true, and if we reach at the last house, we can check that boolean if we have already chosen the first house, then we will not choose the last house. Like what I'm thinking is suppose we call a function find maximum row maximum amount means we can drop. We need this, and we are at zeroth index initially. And what we do, we pass this nums array and also the length of the nums array. Okay, let's say this will return our answer. This function will return our answer. So we are at this index in this array, and this is the size of the array. And suppose we pass a variable like if we have taken the zeroth value or not, means if we are choosing the value at if we are robbing the zeroth house or not. Let's pass this as false, that we are not robbing this house. So let's call this boolean first house. Okay, so if our index means becomes greater than this n, means if after robbing, after iterating all the houses, we will left with the uh, zero house, so we have nothing to rob, so we will return zero. Okay, so this is the base case. So when standing at a house, we have two decisions to make. The first one is we can rob the house or we can skip that house. Suppose first we skip that house. Okay, and we'll store that result after skipping the house. What will be the result? So we have skipped the current house and we are moving to the next house. Okay, we are moving to the next house, passing this and this, and still our first house will be unrobbed. So we will return this itself, whatever its value. Okay, so we need charger. Hello. Okay. Okay, so we will not rob this house. Then other option will be we rob this house. So what we will do, we will rob this house, this particular house, and if we rob a house, then wait a second. This If we rob a house, then we cannot rob the adjacent house too. We will increment index by 2. That we cannot rob the very next house, so we will move to the next house, and we will pass our nums and n. Now we need to decide that if we have robbed our first house or not. But in recursive calls, this function will be called for many values of index. So suppose we check, we what we'll do, we will check if our index is 0. Then in that case, what we can do, we can make this variable as true, that index is 0 and we are deciding to rob the 0th house. So now we can pass this variable. So we are making true it before robbing the 0th house. Okay. And at the end we will return maximum of the skipped part, maximum of the call in which we have skipped and robbed part. Now one thing is left, that we need to handle the last house. Means we cannot rob the last house if we have robbed the first house. So index of the last house will be n minus 1. So we will also need to handle the n minus 1th case. Okay, if we are robbing this house, what we need to do, we need to take the value, means the money at this house. Okay, how we can handle it for the last house? If we are at the last house, means if we are at the last house, we, if our this variable, means if first house is robbed, then we will not take the value at the last house. Okay, means we will not rob the last house if first house is already robbed. So let's add a condition here, like if our index is the last house and our first house is robbed, then we can't rob the last house. So we can return from here. Means if we are at the last house and we are not deciding it, then that's the last possible value which we can take. So we can check this as a base condition also, because skipping the last house will eventually uh, put out us from the array. Means n minus 1 plus 1 will be n, and that condition eventually will return 0. So we can return 0 here also. Okay, means if we are at a last house and we are deciding, we our first house is already robbed. Okay, let's see if this works. Okay, we need to have a semicolon here. Okay, it's working at least for these cases. Okay, now I think we can apply DP. So before applying DP, we need to see that how many parameters are changing in our function call. So here one variable is this in IDX, and second one is this first house row. Means this variable is changing. So the two variables are changing. So we can create a 2D DP. New int will be of size n and 2 means true and false. For true we will store 1, for false we will store 0, and we will initialize our values in DP as let's say with -1. Means I didn't understand. If we are robbing first house, then we will not rob the last house. Means we are passing true if we are robbing the deciding to rob the first house. Means I didn't understand what you are saying. You are sending false, right? Where is true? Which line number? From main function. Okay. Okay. Suppose we have. Okay. Okay. Understood. We are sending false here. Okay. So suppose my array only have this house means house number 4. So in that case, my index will be this, but my first house will not be robbed. So I will go to this condition. Skipping will give me 0, and choosing this will give me the 4. Okay, this is not failing for the single edge case. Now suppose I have 4 and 5 in my let's say 4 and 5 in my 4 and 5 houses. So if I start from this house, so initially I'm putting a false that I haven't taken the value at the first house. So means till now we haven't made the decision that we have chosen a value or not. That's why I'm passing false. Means can you tell me a test case where you are thinking that it can fail, so that we can think. Bro, do you know Hindi, or I think you are from Hyderabad, I think. Or Hyderabad, or from where are you, bro? Aeronautical engineering, Hyderabad. Okay. Okay, 5-4. So in 5-4. Okay. So okay, 5-4. Okay, 5-4 answer will be 5 because we will rob only this house. Okay, so suppose we pass false here, and now we reach here. When we suppose we skip this house. Okay, First call is we can skip this house, and second call is suppose we skip this house. Let's go with the recursion itself. So suppose we skip the first house and we haven't taken anything. Then for this call, now index will be 1. So we come here and we see that index is 1 and first house is okay. So this condition will not pass because first house is not robbed. Then for first index we will call skip custom test case. Okay. Let's apply a DP. Mm, for applying DP, what we can do, we can pass the DP here. Means int DP, so initialized by -1, and we can see if okay, if DP of let's say IDX and okay, we will gonna need this. Okay. I think this will do the job for us. Okay, we need to pass it from function calls also. Okay, let's submit this. And there should, I think, exist a solution using 1D DP also. Means if I was if asked this problem in interview, I will be means I should have written this code only. Let's see my previous submissions. Okay. What I have done here is I have okay. I have either considered the first n minus n elements, or in the second part I have considered the next n minus n elements. and then called this function for both, called dp for both, and then it I have solved it using 1D dp. But there maybe I think some better solutions. Don't know, bro. Messy code. Okay, let's see some solutions using 1D dp. Top down recursion. Okay, recursive solution. So what we are doing in recursive solution, taking this. Okay, if we are including a variable. No, this solution is good, I think. Okay, so okay, means he's also applying DP two times. Means calling the DP functions two times. First for the he has taken two nums array, first nums array and second nums array, and if I is not equal to zero, okay. So I think yeah, you are correct. This is the only DP solution, a 1D DP solution. Basically, our solution is taking our solution is taking 2 into n time, and the means our time complexity of our solution will be 2 into n, which will be big of n, and the same will be for the 1D solution. No, it's also efficient, bro. It's only uh, it comes into mind in the interview. Yes, good interviewers only look for the better approach. They don't need any uh, working solution. They just need how we approach a problem. That's it. In my interview, the company in which I am, I had a I had just one interview round of 35 minutes. That's it. The interview has asked me a backtracking question, And after I have written the code, and when I was going to hit the run button, he said, before running, uh, verify your code. You can only run your code once. Otherwise, if it fails to run the interview, we will end the interview here itself. Okay. So I think that is it for today from my side. We can solve this problem tomorrow, alien dictionary, and tomorrow I will be doing work from home, so we can solve more problems, I think. Okay. So you dry run on paper. Mm, uh, means he asked me to. I asked him that where I can code. So he said that you can code anywhere you want. So I have chosen IntelliJ because it has an inbuilt compiler. So it helped me to avoid syntax errors. The only thing I need to check was the logic of the code. And I think I was asked the question. I think it was a simple question. Means using backtracking, I think I have to find all the ways to uh, all the ways to reach a target, means adding the numbers and target. It was a simple backtracking problem, and one DP problem was also there, and some questions from React and some behavioral questions. In 35 minutes he asked everything. And also he was asking me about threads, so I said I don't know about threads. So that was the only thing I was not able to answer. He asked me that how we can print the currently running processes in the Java. I didn't know. Till the date I don't know how to do that thing. What was that question? And the person who interviewed me, I almost, means I sit just near him. Means he was not from our team. He was from some upper management. Okay, guys. Good night. How can you do that for recursive ones? What you are saying? What for the recursive ones? Can you do for the recursive ones? Plan means, okay. Plan after this sheet. I'm thinking of doing some design problems, like the problems which are asked in machine coding round. So I think it may have some problems from the design part also. So I haven't gone through these problems, that what are these. Means we will pick some design problems. Means some problems, machine coding round, like Misho has a machine coding round, Flipkart also has a machine coding round. So we will target that part. Means discussing design pattern on a stream will not be fruitful. Means we can learn, means it's all theory in Means design, system design is all about theory, so we can just read a book and pass the interview, but we need coding, good coding practice for machine coding wrong. Other than that, I'm working on a project, so which is in Golang. It is initial. It is now in a initial stage. Means I haven't done much of it. So let me show you quickly. You can also do company specific. So this is you I you can look for it. Means Golang is easy if you want to contribute. You can give me a second. Let me share my GitHub link to you. Okay, thank you. I'm messaging you on LinkedIn.